Hello everybody, this is Absolute Value Inequalities unit. In this video we are going to learn how to solve the absolute value inequalities. We will start with the steps. We will learn how to solve the absolute value inequalities and the conditions step by step. So as any other inequality or equation, first of all we always isolate the absolute value expression. The absolute value expression here, it has the variable, so we isolate it in the left side of the inequality. In step number 2, it's a decision stage. We will take a decision in this step whether to proceed to step number 3 or to stop here. So the decision is all about the right side or the other side of inequality. We have the absolute expression in the left and we have the other number or constant on the other side. So if it's the sign of other side of inequality is negative and the inequality is greater than or equal negative number, then the inequality has, when we say the absolute value, we mean a positive number. For always it means a positive number or positive value. If it is a positive value greater than or equal to a negative number, this statement actually is always true. Always a positive number is greater than or greater than a negative number. So in this case, the absolute inequality has all the real numbers as a solution. If the right side of inequality is negative, but the sign or the symbol of inequality is less than, the statement becomes a positive number, which is the absolute value, less than a negative number, which is always not true. This statement is not true. So in this case, there is no solution for this inequality. Either all the real numbers or no solution. If the other side of inequality is negative, we stop here at this stage. If the other side of inequality is positive, then move to step number 3, which is removing the bars of inequality. When we remove the bars of inequality, we are actually setting a combined inequality. And this combined inequality, to decide whether it is an or combined inequality or and combined inequality, we decide this by the symbol or the sign of the inequality. If it is greater than, in the problem, if it is greater than, then we are setting in an or compound inequality, or. But if the symbol is less than or equal, then we are setting an and inequality, which is always the expression in the middle, and we have the both positive and negative numbers at the other sides. And inequality has 3 sides. So let's take these steps and apply them on examples to see how does this work. First example here is the absolute value of x plus 4 minus 6 less than 9. First we are going to isolate. We need to isolate the expression that has the absolute value. So in this case, 9 plus 6, 15. This is the decision-making step. We are looking to the other side of inequality. It's positive. So we proceed. If it is positive, we proceed to the step number 3, which is removing the bars. When removing the bars, we will decide whether it is an and or inequality, compound inequality. We'll decide this is the symbol. It is less. Since it's less, then we have and inequality. So what's and compound inequality? We take this expression in the middle, which is less than 15 and greater than minus 15. Now we are isolating the x by subtracting minus 4 from all the sides of inequality. Now x is less than 11 and greater than minus 19. So this is the solution. We can express it like this. It is between parentheses 11 to 12. It's open parentheses. It means that either minus 19 and 11 are not included in the solution. So minus 19 is not a solution and 11 is not a solution as well. But all the numbers between minus 19 and 11 . Let's take another example, the absolute value of 2x minus 1. Minus 7 is greater than or equal to minus 3. First, we need to isolate the expression of the absolute value, so we add plus 7 to both sides of inequality. So now we have the absolute value of 2x minus 1 greater than minus 3 plus 7, it's plus 4. So it's a positive number. We proceed by removing the bars of the absolute value expressions. In this case, it's greater than. Since it's greater than means or compound or combined inequality, as we have learned previously. So we have two inequalities. 2x minus 1 is greater than or equal to 4, or 2x minus 1 less than or equal to minus 4. Let's start to solve both of inequalities. The first one, we add 1 to both sides of inequality. Then 2x is greater than or equal to 5. Divide by 2. Then x is greater than or equal to 5 over 2. Or in this case, add 1 for both sides of the inequality. We have 2x less than or equal to minus 3 over 2 over 2. Then x is less than or equal to minus 3 over 2. This is the solution of this inequality. It means either x is greater than or equal to 5 over 2, which is 2.5, or x is less than minus 3 over 2. Any value from any group of these will can be applied in this inequality. We can express it by x greater than 5 over 2. It is 5 over 2 infinity and in this case we have from minus infinity to minus 3 over 2. This bracket means that minus 3 over 2 and 5 over 2 are included in the solution. Let's take other examples. This example here, the absolute value of 5x plus 6 plus 4 less than 1. The first step is to remove 4 by subtracting minus 4 from both sides of inequality. So 5x plus 6 less than 1 minus 4 minus 3. Now it is a decision-making step. After isolating the absolute value expression, we need to decide whether to proceed to the step number 3 or stop. This absolute value means it's a positive value. Always, absolute value, always a positive value, less than a negative number. This is not true. So this inequality has no solution. And we stop here. If the symbol is greater than, the solution will be different. Now let's see this example here. The absolute value of 3x minus 4 plus 9 is greater than 5. We start with isolating the variable or the absolute value expression. We are subtracting 9 from both sides of inequality to give us the absolute value of 3x minus 4 greater than to 5 minus 4, it's minus 4. In this case, 3x minus 4 is a positive value, since its absolute value means it's a positive value. It's greater than a negative value. This true? Yeah. The statement is always true. What does that mean? Since the statement is always true, though, the solution is all the real numbers. We finished this session. I hope this was informative and helpful for you. See you guys next time. Thank you.